page 5 of the C programming notes. That last page was really short, so if you're wondering if you missed something, no you didn't. I just forgot to say that. Okay, the section also covers unions, and I'm guessing that most of you have not seen a union before. And a union, means bringing things together and making them a whole. In this case, it's more of kind of merging things, overlapping them. So unions overlay their fields in the same spot in memory. And probably an example is the best way to explain. So here's another full program. Not all my examples will be full programs, but this one is. And I'm going to do another type def. This time I'm type defing a union. So it's another keyword. And it looks like a lot like a struct, but it's quite different. So we're going to have an integer that's a num, and for this example, again, we are going to assume that is 4 bytes. Integers, we're going to talk about integer sizing later. It can be anywhere from 2 bytes to, it really doesn't have an upper bound. It depends on the processor you're working on. So 4 bytes is common, 8 bytes isn't uncommon, and so on. And then we're going to have a char, and I'm going to just call this byte. So we're assuming a char is 8 bits, and it's an array of 4. And so the num, those 4 bytes, are going to overlap. They're going to use the same storage and memory as this array of 4 chars. And that's the whole union. I need to give it an identifier, so let's call it num byte type. And let's just draw a picture of this thing. It's going to be 4 bytes total. And I'm going to do dashed lines here. And let's switch colors. The num field references all 4 bytes, and it starts from the first one, byte 0, I guess. But then we've got this array of array of chars with the name byte. And so byte element 0, byte element 1 will go in the next location, byte element 2, and byte element 3. And this whole thing is our num byte type, how it's going to be laid out in memory. Show what happens. So here is our main function, int return type, void parameter list. And just while I'm on the topic, when you're declaring or defining a function, the thing in brackets, or the list of things in brackets, is your parameter list. When you're invoking a function or calling it, then those are arguments. So if you like nitty-gritty stuff, there you go. So let's create, or let's declare a variable of our num byte type, and we'll call it MB for short. And I'm going to use the number field to assign a value to it. This is how you specify a hexadecimal constant in a C program, so 0x. I'm not going to, typically with my, well, maybe I'll do put the slashes through the zeros for this too. I often leave out the slashes and the zeros that are part of the hex number. Okay, and so what that is going to do is it's going to populate, let's just say that this is our num byte storage, and if we are using little endian byte ordering, then the least significant byte will go at the smaller address. So least significant byte is 04, and so it goes up here at byte 0, and then the next least significant goes next, and so on until we get to the most significant. If it had been big endian ordering, then we would have had the 01 at the top and 04 at the bottom. Alright, and now we're going to print out the contents of each of those locations. So here is a new conversion specifier. %x says that you're printing out a hexadecimal constant, and the 8 says to make it 8 characters wide, it will be right justified, and the 0 says to pad the left, so any unused spaces, pad it with zeros. I'll add that explanation after. And so then we're going to print each of the bytes as a decimal value. And again, we're going to use 2 digits for each byte, and we're going to 0 pad it. We're going to do that 4 times for each of the bytes. And I think I could have done %0 to x instead of %0 to d, and would have gotten the same effect. Not sure why I went with the d, but anyway, that's what I did when I programmed this thing. So first, we're going to print out the num, that's that 4-byte value, and we should just get printed out what we wrote, the value that we assigned to it, the 01, 02, 03, 04. But now we're going to print out the bytes in order. So nb dot byte 0. It's a little tedious. We got to do this 4 times. nb dot byte 1, nb dot byte 2, and nb dot byte 3. The name byte there is just an identifier. There's nothing special about it. And what we're going to get for our output, actually, before I do that, let's close our main here. So that's the whole program. Our output is going to be the 32-bit value. And when you print with the the %x conversion specifier, it doesn't stick that 0x in front of it. You just get the hexadecimal digits. And then that's followed by for the 4-byte values, and they're going to be in the order that they're stuffed into memory there. Whoops, I don't want a comma. So it will be 04, 03, 02, 01. So there's our output. And I'll just add a note about this conversion specifier here. So this is the hexadecimal conversion specifier. I'm having trouble writing. And we added some numbers that indicate that it should be 8 digits. It will be right justified. I think there's a way to left justify, but I'm not sure about that. Right justified, and it will be 0 padded. So if we left out the 0 and it was just %8x, then it would just leave a space instead of a 0 on the right side. So that's it for this page. But just illustrating how the union overlaps different fields in the same location, and this will be useful later when we do memory mapped I/O.